Imagine this. You are lying in the quiet of your room, the world around you slowly dimming into silence. A soft whisper carries you beyond the walls, beyond the familiar night sky, and into the depths of the universe itself. What if the stars above were not just distant points of light, but markers of scale, each one inviting you to measure, to wonder, to compare? Hey guys, tonight we are embarking on a journey that blends science with serenity. Together, we will compare the unimaginable sizes of planets, stars, galaxies, and even the universe itself, moving gently from the scale of our home on Earth to the very edge of the cosmos. Our goal is not to rush or overwhelm, but to drift slowly through these comparisons, like floating on calm cosmic waters. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And if you feel like sharing, let me know your location and the local time where you are right now. It's always beautiful to imagine listeners scattered across Earth, connected under the same stars. Now, if you're ready, let's begin. When you look up at the night sky, what you see is only a whisper of infinity. Stars sparkle like grains of sand, yet behind them lies a scale so immense it can hardly be captured by the human mind. The universe is vast, yes, but how vast? That is the question that will guide us. Tonight, instead of racing to the answer, we'll walk slowly, step by step, like travelers strolling along an endless shoreline. Each wave that reaches us carries a story of size, a story of proportion, a story of comparison. We begin here, on Earth. Earth, our home, our blue marble, seems enormous in daily life. Mountains tower, oceans stretch beyond horizons, and the sky itself feels boundless. But compared to the wider universe, Earth is just a quiet note in a grand symphony. This realization does not diminish our home, it makes it even more precious. For something so small to host life, memory, and thought, that is a miracle in itself. Size comparison is not just numbers or diagrams, it is the poetry of perspective. Imagine standing on a beach, holding a grain of sand in your hand. That tiny grain is Earth, compared to larger planets, compared to stars, compared to galaxies. But within that grain lies oceans, forests, and billions of human lives. Perspective does not make us insignificant, it deepens our awe. Scientists have long tried to measure the universe not to make us feel small, but to remind us of the richness of scale, distances, diameters, and volumes. They all tell stories. The moon's size compared to Earth's, Earth's size compared to Jupiter's, Jupiter's compared to the sun's, and the sun's compared to the largest stars ever discovered. Each step upward is like lifting another curtain, revealing stage after stage of cosmic grandeur. And yet, in all this, there is a softness. Because when you imagine these comparisons not in harsh data, but in gentle images, they become like lullabies of proportion. The universe is big, but the journey to understanding it can be calm, soothing, and strangely intimate. What lies beyond Earth is not just vastness, but an invitation. Infinity whispers, "Come see how I stretch. Come see how I unfold." From the hum of electrons within atoms to the roar of galaxies across billions of light years, the universe offers comparisons in every direction. It is as if the cosmos is a grand storybook, and tonight we turn its pages slowly, letting each image rest in the mind before moving on. We will compare Earth with other planets, then with the Sun, then with stars so big they could swallow entire solar systems. We will compare galaxies, clusters, and the grand web of the universe. And finally, we will circle back to reflect on ourselves how small, yes, but also how unique we are within this expanse. So, tonight's journey begins not with numbers, but with wonder. You do not need to remember every measurement or fact. Instead, you can let the rhythm of scale wash over you. Earth, Planets, stars, galaxies, universe. From small to large, from familiar to unimaginable. Like a lullaby in stages, each step a gentle escalation. Each comparison another soft note in the cosmic song. And so we stand here, at the shoreline of infinity, ready to take our first true step outward from the size of our home, Earth, into the wider cosmic neighborhood that surrounds us. When we take our first gentle step outward from Earth, the comparisons begin close to home. Imagine yourself floating just above the surface of our world, looking down at the oceans, the continents, the faint glow of city lights scattered like fireflies. Earth feels immense when you live upon it. Yet as soon as you compare it to the space beyond, it begins to shrink into a delicate sphere suspended in darkness. To understand the scale of home, we must measure Earth against its closest companion, the Moon, and then extend that thought to our neighboring worlds. The Moon, glowing softly in the night sky, feels large when it rises above the horizon, yet in truth, it is just over 1/4 the size of Earth. If Earth were a basketball, the Moon would be a tennis ball drifting nearby. The comparison is both humbling and comforting. We live on the larger partner of this cosmic duet, and yet the smaller body has guided our tides, marked our calendars, and inspired endless stories. When astronauts looked back at Earth from the Moon's surface, they saw our planet as a fragile blue orb, almost small enough to cradle in 2 hands. That vision tells us everything we need to know about scale. Perspective changes everything. Expanding outward, Earth belongs to a family of planets. Mercury, the smallest, is less than half the size of Earth, a rocky world, scorched by its nearness to the Sunday. Venus, by contrast, is Earth's near twin in size, though wrapped in suffocating clouds of carbon dioxide. Mars is only half as wide as Earth, a world of rust and dust that once flowed with water. When you place these planets side by side in your mind, Earth does not seem so lonely. It is part of a quiet neighborhood, with siblings of various sizes, each carrying their own stories of geology, climate, and possibility. But then your thoughts drift to the giants. Jupiter, the king of planets, is more than 11 times Earth's diameter. If Earth were a small coin, Jupiter would be a massive dinner plate beside it. The scale is staggering. More than 1,300 Earths could fit inside Jupiter's volume. Saturn follows, slightly smaller, but still vast, its elegant rings stretching wider than the distance between Earth and the Moon. These gas giants remind us that size can exist on an entirely different level. Our home planet, so grand in our daily lives, becomes almost invisible when compared with such enormous spheres. As you hold these comparisons in your mind, imagine lining up all the planets of the solar system in order. Mercury is like a pebble, Earth a modest stone, Jupiter a towering mountain. The range is breathtaking. And yet, despite the vast difference in size, all these worlds orbit the same sun, drawn into harmony by the same invisible thread of gravity. It is as if the universe is whispering that even small things and large things share the same dance. Returning to Earth for a moment, let us reflect on its place among these companions. Earth is neither the smallest nor the largest, neither the most hostile nor the most welcoming. It is balanced just the right size to hold onto an atmosphere, just the right distance from the sun to allow liquid water, just the right mass to sustain a magnetic field. This balance gives rise to forests, oceans, and the breath of life itself. When compared to the extremes of other planets, Earth's size seems perfectly tuned, as though the universe itself arranged conditions for comfort. The act of comparing scales invites both science and wonder. Scientifically, we measure diameters and distances. Earth is about 12,700 kilometers wide, the Moon about 3,500, Jupiter about 143,000. Numbers give precision, but it is the image of placing these bodies side by side that lingers in the mind. You can picture the moon tucked beside Earth, like a faithful companion, Jupiter looming in the distance like a colossal guardian. These images transform data into poetry, turning astronomy into a lullaby. The more you reflect, the more you see how scale changes perception. To a human standing on Earth, the planet feels boundless. To an astronaut circling in orbit, Earth is a fragile globe. To someone standing on the moon, Earth is a glowing sphere in the distance. And to the sun, Earth is nothing more than a tiny marble among many. Scale is not fixed, it is always relative. Understanding this gently humbles us, reminding us of our place while also deepening our connection to the cosmos. As you drift in thought, imagine yourself gliding slowly outward from Earth, watching the moon orbit gracefully, then passing by Mars, Venus, and the other siblings of our solar family. The farther you move, the smaller Earth becomes, until it resembles a single shimmering bead of blue light. It is at once small and infinite in meaning. This is the paradox of scale. The universe makes us seem tiny, but in that very realization, we discover the immeasurable value of home. The scale of home is not just about size, it is about belonging. Earth is the stage where every story of humanity has unfolded. It is where we learned to measure, to compare, to wonder. To say that Earth is small compared to Jupiter is true. But to say that Earth is vast compared to a human being is equally true. Each layer of comparison reveals another perspective, another way of feeling the universe. And so, as we rest in the gentle knowledge of scale, we carry with us a sense of balance between the immensity of the cosmos and the intimacy of our lives within it. From this foundation, we are ready to drift further outward. Beyond the planets lies the source of light itself. The Sunday, compared to the giants of our solar system, Earth shrinks to a tiny pearl. But compared to the Sun, even Jupiter fades into insignificance. The next step in our journey will be to compare our familiar star with the vast cosmic fires that blaze across the galaxy. And in doing so, we will continue to whisper with infinity, one scale at a time. As we drift further from our fragile blue world, our gaze is inevitably drawn toward the giants of the solar system. If Earth feels vast in our daily lives, the gas giants reveal another order of magnitude entirely. They are the colossal guardians of our planetary family, their immense gravity shaping orbits, steering comets, and holding moons in their embrace. When we compare Earth to these giants, we begin to sense just how many layers of scale the universe holds, each one larger and more humbling than the last. Jupiter comes first, a world so large that it dominates every thought of planetary comparison. More than 11 Earths could line up across its diameter, and if you could scoop Earths into a cosmic jar, over 1,300 of them would fit within Jupiter's volume. Imagine Earth as a small bead of glass. Place that bead beside Jupiter, and the giant swells into a globe so enormous it seems almost unfair. Jupiter is not just big, it is overwhelming, a gas sphere swirling with storms the size of entire planets. The great red spot alone, a storm raging for centuries, could swallow Earth without effort. To compare our home with Jupiter is to glimpse the enormity of nature, reminding us that we occupy only one rung on a vast cosmic ladder. Beside Jupiter stands Saturn, slightly smaller but adorned with beauty that sets it apart. Saturn's rings stretch outward like a delicate crown, vast sheets of ice and rock, orbiting in perfect formation. If you place Saturn beside Earth, the comparison would again leave you breathless. Saturn is about 9 times Earth's diameter, large enough to fit hundreds of Earths inside. And yet, for all its size, Saturn is light, its density so low that if there were a cosmic ocean vast enough, Saturn would float. The juxtaposition is astonishing. A planet so large and majestic, yet delicate enough to balance upon water. As we contemplate these comparisons, we begin to realize that Earth is neither insignificant nor supreme. It belongs to the middle ground, a balanced planet with just the right proportions to sustain life. Compared to Mercury, Earth is a giant. Compared to Jupiter, Earth is a speck. Perspective is everything, and scale always depends on where you place yourself along the spectrum. But the giants do not stand alone. Uranus and Neptune, the ice giants, follow at greater distances, smaller than Jupiter and Saturn, but still enormous compared to Earth. Uranus is about 4 times Earth's diameter, a pale turquoise globe tilted on its side, rolling through its orbit like a cosmic barrel. Neptune, deep blue and mysterious, shares a similar size, with winds that roar faster than any hurricane on Earth. Each of these giants carries moons of its own, some nearly the size of our own planet. To imagine them together is to picture a family of giants watching silently from the edge of the solar system. The gas giants also reveal another layer of comparison. They are not solid in the way Earth is. While our planet has a firm surface to walk upon, Jupiter and Saturn are made mostly of hydrogen and helium, gases compressed under immense pressure. If you could descend into Jupiter, you would sink through layers of atmosphere until, crushed by gravity, the gases transformed into strange metallic states. The giants are both familiar and alien worlds of immense size, but unlike anything we could truly stand upon. This contrast deepens the poetry of scale. Not only are they larger, but they are fundamentally different. From a distance, the solar system looks like a hierarchy of spheres. Small rocky planets huddled close to the sun, and vast gas and ice giants orbiting farther out. In this layout, Earth is neither at the bottom nor at the top. It is somewhere in the middle, balanced between the extremes. This placement feels symbolic, as if Earth's role is not to dominate with size, but to nurture with balance. Perhaps it is not always the largest that matters most, but the one that sustains meaning. Reflecting on these giants, you may feel a quiet shiver of humility. To think of Earth alongside Jupiter is to imagine a tiny sailboat drifting near an ocean liner. To compare Earth to Saturn is to picture a small candle burning beside a vast bonfire. And yet, the candle has its own flame, its own fragile warmth. Earth, though smaller, is not less important. For within its modest dimensions, it carries oceans, forests, voices, and dreams, things far rarer than storms and rings. These comparisons invite us to consider a larger truth. Size alone does not determine significance. The giants rule with mass, but Earth rules with meaning. Jupiter may bend comets, but Earth bends thought. Saturn may wear rings, but Earth wears life. The comparison becomes not just a measure of distance or diameter, but of essence itself. Still, the giants remind us of the scales waiting beyond. If planets can differ so greatly, what about the stars that bind them together? If Earth shrinks beside Jupiter, how will Jupiter shrink beside the Sun? Already, the mind begins to prepare for another leap in perspective, another stage in the cosmic ladder. The giants are enormous, yes, but they are only waypoints on the journey outward. Beyond them lies the true source of scale, the stars. As we drift past Jupiter's whirling clouds and Saturn's shimmering rings, we begin to feel the pull of sunlight. The sun, so familiar in daily life, is about to take on a new identity in comparison. For compared to the giants, the sun is a colossus, and compared to other stars, it is only modest. Each step outward magnifies the lesson. Scale is endless, infinity layered upon infinity. The giants prepare us for this next revelation, giving us a bridge from the world we know to the stars that lie ahead. So, let us carry forward this gentle knowledge. Earth is small beside the giants, yet it remains central in meaning. The giants are vast, but they remind us that larger stages await. In the grand theatre of the cosmos, every actor has a role, some grand in size, others grand in significance. As we leave behind the shadows of Jupiter and Saturn, we turn our gaze toward the sun, ready to see how even the giants bow before the fire of a single star. After drifting past the gas giants and their towering presence, the scale of the solar system invites us to turn in the opposite direction. For every massive sphere like Jupiter, there are countless tiny worlds scattered across the darkness. Small planets, dwarf planets, moons, and asteroids. These bodies may be diminutive in size, but they remind us that the universe is not only built on grandeur, it is also shaped by subtlety, by quiet companions that orbit unseen, by pebbles and fragments that still carry stories of creation. To understand scale fully, we must not only look at what is vast, but also at what is small. Let us begin with Pluto, once known as the ninth planet, now reclassified as a dwarf planet. When compared with Earth, Pluto is astonishingly tiny, barely 2/3 the size of our moon. You could line up nearly 6 Plutos across the width of Earth. And yet, despite its smallness, Pluto carries its own atmosphere, its own icy mountains, and even plains of frozen nitrogen. Imagine a world where mountains are made not of rock, but of water, ice-hardened like stone in the cold. This is the poetry of scale. A small body that still contains grandeur in miniature. Pluto is not alone. Beyond Neptune lies a whole belt of such icy objects known as the Kuiper Belt. Here, dwarf planets like Eris, Haumea, and Makemake drift silently. Each is smaller than Earth's moon, and yet each represents a fragment of the early solar system, a frozen relic from the time of creation. They are the crumbs left over after the great feast of planetary formation. To compare them with the giants is almost absurd. Jupiter could swallow them without noticing, and yet to ignore them would be to miss the whisper of history written in their frozen shells. Closer to home, we find other small companions that illustrate the contrast of size. Take Ceres, the largest object in the asteroid belt between Mars and Jupiter. Though it holds the title of dwarf planet, Ceres is still only about 1/4 the size of our moon. To picture it, imagine Earth reduced to a marble, and Ceres no larger than a grain of rice beside it. And yet, recent studies show that beneath its crust may lie a hidden ocean of salty water, perhaps even environments that could nurture microbial life. Smallness does not mean emptiness. Scale can deceive the eye, hiding depth in the most unlikely places. Beyond the recognized dwarf planets, the solar system swarms with asteroids and comets. Some are no larger than mountains, others mere boulders tumbling through space. To compare one of these rocky fragments with Jupiter feels almost humorous, like placing a pebble beside a cathedral. And yet, these pebbles are ancient, older than Earth itself, carrying the original dust and stone from which worlds were built. They are the seeds of planets, reminders that even the giants began as something small. In their tiny size, they carry the memory of growth. The moons of the solar system also reveal this contrast. While some, like Ganymede or Titan, are larger than Mercury, most are far smaller. Phobos, one of Mars's moons, is just 22 kilometers across. That is smaller than many cities on Earth. If you were to stand on its surface, the horizon would curve quickly around you, so close you could almost stretch out your arms and trace the edge of the world. And yet, Phobos is a world in its own right, with craters, valleys, and a silent orbit around Mars. Scale invites us to see significance, not in size, but in uniqueness. Imagine, for a moment, placing all these bodies in a row. Jupiter, vast and swollen. followed by Saturn with its shimmering rings, then Neptune and Uranus, smaller but still immense. After them, Earth, solid and balanced, accompanied by its moon, Mars, Mercury, and Venus, line up as modest neighbors. And then, like a delicate string of pearls, Pluto, Eris, Ceres, and the countless smaller bodies beyond. The range of sizes is staggering. From worlds that could engulf thousands of Earths to rocks no larger than a mountain, the solar system stretches across an unimaginable spectrum. What is most humbling is that these tiny worlds, though small, are numerous. While there are only a handful of giants, there are countless minor bodies, asteroids, comets, fragments, moons. The universe seems to remind us that smallness is not rare. It is the most common state of being. Stars may be enormous, but most stars are smaller than our Sunday planets, may reach the size of Jupiter, but most are more modest. In fact, the universe appears to prefer the small, scattering them in abundance across every corner of space. This comparison also mirrors life itself. On Earth, mountains are grand, but grains of sand are countless. Oceans are vast, but drops of water form them. The cosmos reflects this truth. Size dazzles, but multitude belongs to the small. To compare Pluto with Jupiter is to understand not only scale, but the balance between rarity and abundance. Giants impress us, but tiny worlds surround us. There is also a poetic symmetry in how these small worlds connect us to wonder. When children look up at the night sky and imagine adventure, they often dream of stepping onto the moon, or perhaps visiting an asteroid. Small places invite intimacy. You could imagine standing on Phobos and seeing Mars rise, or walking across Pluto beneath a dim Sunday. The giants overwhelm, but the tiny worlds invite us to dream in closer, more personal terms. Their size makes them approachable, as if they could be held in the palm of the imagination. As we compare these scales, we begin to sense the rhythm of the universe. It moves from immense to minute, from giants to grains, from vast orbits to fragile fragments. Each step reminds us that scale is not only about measurement, but about meaning. A dwarf planet may be small, but it carries the grandeur of survival at the edge of the sun's reach. An asteroid may be tiny, but it tells the story of how planets are born. Phobos may be little more than a rock, but it embodies the poetry of a world circling another world. From this perspective, the tiny worlds are not less important, but differently important. They balance the narrative of the giants. They remind us that the universe is not only about magnitude, but also about detail. Without them, the story of scale would be incomplete. They are the punctuation marks in the cosmic sentence, the quiet whispers balancing the thunder of size. And so, as we leave behind the dwarf planets, the asteroids, and the small moons, we prepare ourselves for another leap. For if Earth pales beside Jupiter, and Pluto pales beside Earth, what then of Jupiter beside the Sun? The comparison will again humble us, again astonish us. The giants are immense, but even they are shadows when set against the light of a star. With gentle curiosity, we drift onward, ready to see how the sun stretches the concept of size to an entirely new horizon. We drift now from the tiny worlds that dotted the outer edges of the solar system and turn our gaze toward the blazing heart that holds everything together. If Earth seems small compared to Jupiter, and Pluto seems smaller still compared to Earth, then all of these comparisons dissolve when set against the Sunday. The Sun is not just another member of the planetary family. It is the center, the source, the anchor. It is the quiet star that sustains life, while at the same time it dwarfs every planet we have encountered so far. To understand the Sun's scale is to realize just how delicate the balance of the solar system truly is. Imagine placing Earth beside the Sunday. Our planet, with its mountains, forests, and oceans, would appear like a tiny bead of dust against a giant golden sphere. The diameter of Earth is about 12,700 kilometers. The Sun stretches across 1.39 million kilometers. More than 100 Earths could line up side by side across the face of the Sun, and more than 1 million Earths could fit inside its glowing body. These numbers may seem almost abstract, but if you close your eyes and picture Earth as a small marble held between your fingers, the Sun would become a massive sphere taller than a person standing beside you. It is not just larger, it is incomprehensibly vast. Even Jupiter, that giant of giants, shrinks in comparison. 11 Earths can line up across Jupiter, but only 10 Jupiters could line up across the Sunday. And while Jupiter holds the mass of all the other planets combined, the Sun contains 99.8% of the entire solar system's mass. Every planet, every asteroid, every comet, all of them together, are but crumbs orbiting around this immense fire. The comparison is humbling, because it reminds us that even the giants are shadows beside a star. And yet, despite its enormity, the Sun is not an especially large star by cosmic standards. It is classified as a G-type main sequence star, a yellow dwarf. Even the term dwarf carries a kind of irony. For us, the Sun is overwhelming, yet in the galaxy, it is considered average. There are stars far larger, far brighter, far more luminous. But for now, within the embrace of the solar system, the Sun is everything. It is the giver of light, the weaver of orbits, the gentle presence that keeps life possible on Earth. The surface of the Sun is a seething ocean of plasma, boiling with storms and eruptions. Sunspots bloom and fade, vast dark scars larger than Earth. Solar flares hurl energy across space, waves of radiation that ripple through the solar wind. And yet, from our vantage point, the Sun feels calm, even soothing. We see it rise each morning, glowing golden through the haze, and we forget that beneath its surface burns a furnace of unimaginable power. It fuses hydrogen into helium at its core, releasing energy that has traveled across 150 million kilometers to warm our skin. Every breath we take, every green leaf we see, every ripple on the sea is powered by this quiet nuclear fire. When you think of the Sun's size, it is easy to feel small, but there is another perspective as well. Without this immensity, without this gravitational anchor, there would be no stability for planets to form, no warmth for life to flourish. The Sun's scale is not just a matter of size, but of nurture. It is the parent of the solar system, vast enough to cradle every orbit, constant enough to let fragile worlds grow. To compare Earth with the Sun is to compare a child with its guardian. One may be small, but within the other's embrace, it is safe. And so, the Sun becomes a measure of perspective in more ways than one. It tells us that size can be both terrifying and comforting. Terrifying, because it reminds us that our planet is a speck of dust beside it. Comforting, because it shows us that in the vastness of space, there is a source of warmth and steadiness. Every comparison of scale, from Earth to Jupiter to the Sun, brings with it not only data but philosophy. We are small, yes, but we are also sheltered within something immense. Picture for a moment standing on Pluto, at the edge of the solar system. The Sun would no longer fill the sky as it does on Earth. Instead, it would appear as a bright star, just another point of light in the darkness, though brighter than the rest. And yet, even at that distance, its gravity still holds Pluto in orbit. That is the true scale of the Sun. Its reach extends billions of kilometers, binding worlds large and small, keeping them from drifting into the void. Its size is not only measured in kilometers, but in influence. We sometimes forget that stars themselves are not eternal. The Sun, vast though it is, has a lifespan. It is about halfway through its life, having burned for 4.6 billion years and with about 5 billion more to go. One day, it will expand into a red giant, swallowing Mercury and Venus, perhaps even Earth. Compared to its present state, that future version of the Sun will be far larger. And then, in time, it will shrink, collapsing into a white dwarf, no larger than Earth itself. Even the giants of today may become the small companions of tomorrow. Scale, it seems, is always in motion. As we reflect on this, we begin to sense the deeper rhythm of comparison. Earth is small beside Jupiter, Jupiter is small beside the Sun, and the Sun itself is small beside greater stars. Each step outward humbles us, but also expands our sense of belonging. For in each comparison, we see the universe not as something that diminishes us, but as something that includes us in its vast embrace. And so, the Sun stands as both a giant and a dwarf, both immense and modest, both ordinary and extraordinary. It is the measure by which we compare, and yet it too will be compared against others. As we prepare to leave the warmth of its light and look toward the wider galaxy, we carry with us its lesson. That size is relative, and significance lies not only in dimension, but in what that dimension allows. The Sun may be vast, but it is vast in a way that nurtures life, and that makes its embrace the most precious comparison of all. With this thought, we turn our gaze outward once more. Beyond the Sun lies an ocean of stars, some smaller, some larger, some so immense that even the Sun seems like a speck beside them. To continue our journey is to step beyond the familiar warmth into the broader family of stellar giants. The next comparison will astonish us yet again, showing us how our Sun, for all its power, is only a quiet candle in the cathedral of the Milky Way. Beyond the warm glow of our Sun lies a vast sea of other stars, each one a sun in its own right, each one carrying its own scale and story. When we lift our gaze beyond the solar system, the comparisons shift again. The Sun, which moments ago seemed impossibly vast compared to Earth and Jupiter, now becomes merely one among countless lights scattered across the galaxy. To compare our Sun with its neighbors is to realize just how diverse stars can be, some faint and small, others blazing and immense. The family of stars around us teaches that size is not uniform, but a spectrum as wide as imagination. The nearest star to us is Proxima Centauri, part of the Alpha Centauri system, only 4.2 light-years away. If the Sun were a bright lantern, Proxima would be a dim candle flickering in the distance. Though it is the closest star to us, Proxima Centauri is much smaller than the Sun, barely 1/7 its diameter. It is a red dwarf, the most common type of star in the galaxy. Imagine the Sun as a basketball. Proxima would be no larger than an orange beside it. And yet, despite its small size, it still burns with the same nuclear fire, fusing hydrogen into helium, sustaining its quiet existence for trillions of years. Its smallness gives it longevity, a reminder that endurance does not always belong to the largest. Not far from Proxima lies Sirius, the brightest star in our night sky. At a distance of only 8.6 light-years, Sirius dazzles with a brilliance 25 times greater than that of the Sunday. If you compare the two side by side, Sirius is about twice as massive and nearly twice as wide. Place the Sun next to Sirius, and suddenly, our familiar star appears modest, like a candle beside a roaring torch. Sirius shines with such intensity that it has guided sailors for centuries, its light cutting through the veil of night like a compass in the sky. The comparison reminds us that brilliance does not always belong to the closest, but to those with the greatest radiance. Then there is Vega, a luminous star in the constellation Lyra, about 25 light-years away. Vega is more than twice the size of the Sun, and its brightness is nearly 40 times greater. If the Sun is a steady heartbeat, Vega is a pulsing drum, beating louder and brighter in the cosmic orchestra. Its light reaches us in less than 3 decades, making it one of the most familiar stars in human history. To stand beneath the night sky and see Vega shining is to realize that stars are not equal. Some blaze with a fire that dwarfs our own. As we move further outward, the range of scale grows even more dramatic. Arcturus, a red giant 37 light-years away, glows with a diameter nearly 25 times that of the Sunday. Imagine lining up suns across the surface of Arcturus. You could fit 24 of them side by side. Where our Sun feels large, Arcturus expands like a great balloon, its outer layers swollen as it ages. The comparison is striking. The Sun is steady and young, while Arcturus has grown old and immense. Size, it seems, is also a matter of time. Stars grow and change, swelling and shrinking as they burn through their lives. Another neighbor, Aldebaran, in the constellation Taurus, is a giant star about 65 light-years away. Its orange glow is easily visible, and its size is enormous, more than 40 times the diameter of the Sunday. If the Sun were a coin, Aldebaran would be a dinner plate, its fiery surface radiating far beyond the dimensions of our star. To compare them is to glimpse the future of our own Sun, for one day it too will swell into a red giant, outshining and outsizing the planets that now circle it. The stars around us are not just comparisons of size, they are also glimpses into destiny. But perhaps the most humbling neighbor is Rigel, a blue supergiant about 860 light-years away in the constellation Orion. Rigel's mass is more than 20 times that of the Sun, and its diameter stretches nearly 80 times wider. Its brightness is beyond comprehension, thousands of times greater than our star. To place the Sun beside Rigel is to watch a spark beside a bonfire, a tiny flame lost in a blaze of light. Even at such a distance, Rigel's glow pierces our night sky. The comparison reveals that while our Sun sustains us, it is only one quiet note in the symphony of stellar giants. What these comparisons teach us is that stars come in every scale, from the faint red dwarfs like Proxima, small but enduring, to the blazing giants like Rigel, large but fleeting. The galaxy is a spectrum of light and size. Our Sun, so central to us, is in truth an average star, a quiet yellow dot in the middle of this cosmic range. It is neither the smallest nor the largest, neither the dimmest nor the brightest. Its ordinariness is what makes it extraordinary, for within that balance it nurtures a planet filled with life. To imagine the scale of these stars is to imagine standing in a cosmic gallery. Each star is a painting of light, hung beside the others, some small, some vast, some delicate, some overwhelming. You walk slowly through the gallery, pausing at each frame, feeling the shift in scale. Earth beside Jupiter, Jupiter beside the Sun beside Sirius, Sirius beside Rigel. Each step is another revelation, each comparison, another brushstroke in the portrait of infinity. And yet, even as we marvel, there is comfort in remembering that scale is relative. To Proxima, the Sun would seem enormous. To Rigel, the Sun is tiny. But to us, it is just right, large enough to sustain us, stable enough to endure, close enough to warm us, distant enough not to consume us. Size is not just a number. It is a relationship, a balance between star and planet, between fire and life. As you let these images drift through your mind, you may feel a sense of calm. The stars are vast, yes, but they are also steady. They have burned for millions or billions of years, their light crossing space to reach your eyes tonight. The comparisons may humble us, but they also connect us. For in every size, in every brightness, we see a different expression of the same cosmic fire. And so, As we leave behind our neighboring stars, we prepare for another step in scale. We have seen the Sun compared with Sirius and Rigel, with Proxima and Vega. But there are stars even larger, even more unimaginable. The blue giants and the red supergiants await, stars so vast that they could swallow our Sun many times over. To continue this journey is to step once more into astonishment, ready to see just how immense the universe can become. The farther we travel from our familiar Sun and its nearby neighbors, the more astonishing the comparisons become. We have seen Sirius outshine, Vega dazzle, Rigel blaze like a cosmic torch. Yet beyond even these familiar names, the galaxy holds stars so vast, so luminous, that they challenge imagination itself. These are the giants of light, the blue supergiants, stars that burn hotter and brighter than almost anything else in the cosmos. To compare them with our Sun is to step from the warmth of a hearth into the roar of a furnace, from a candle's glow into the blaze of 1,000 torches. Consider Deneb, the brightest star of the constellation Cygnus, nearly 2,600 light-years away. Its distance makes it appear faint compared to nearby stars, yet in truth, Deneb is one of the most luminous stars visible to the naked eye. If it were placed where our Sun is, Deneb would cast shadows even in the day, outshining everything in the sky. Its diameter is more than 200 times that of the Sun, and its brightness is over 100,000 times greater. Imagine the Sun as a single lantern in the night. Deneb would be a floodlight so fierce that its beams would reach across continents. The comparison humbles us again. Our Sun, so central in our lives, becomes almost invisible beside such brilliance. Then there is Rigel, already introduced, but let us pause and truly dwell upon its scale. Rigel is a blue supergiant, about 860 light-years away, with a radius nearly 80 times larger than the Sun and a luminosity tens of thousands of times greater. Its light cuts through the fabric of Orion's belt, anchoring one of the most iconic constellations in human history. Imagine the Sun glowing quietly at the center of our solar system, then imagine Rigel in its place. Its sheer energy would strip Earth of its oceans, its atmosphere, its fragile balance. Life could never have begun under its furious blaze. And yet, from afar, we see Rigel as beautiful, a brilliant gem in the tapestry of stars. Size can nourish, as the Sun does, or overwhelm, as the giants of light do. The blue supergiants are short-lived compared to the Sunday, where our star will burn gently for billions of years. These titans live only a few million before exhausting their fuel. Their size, their brightness, their immense scale come at a cost. They live quickly, they burn intensely, and they die spectacularly, often as supernovae that scatter elements across space. In this way, comparison is not only about size, but about time. The Sun is modest but enduring. Deneb and Rigel are enormous but fleeting. Each carries its role in the cosmic balance, one sustaining life, the other seeding creation with heavy elements after its fiery death. Let us turn to another star, Zeta Puppis, a blue giant nearly 60 times the mass of the Sunday. It burns with a surface temperature twice as hot as our star, pouring out ultraviolet radiation and stellar winds so fierce they strip away material from its surface. Its light would overwhelm our skies if placed closer. Comparing Zeta Puppis with the Sun is like comparing a roaring storm with a gentle breeze. Both are forms of wind, both are forms of energy, but the scale is utterly different. And then there is the extraordinary star Alnilam, one of the 3 bright jewels in Orion's belt. Alnilam is more than 30 times the Sun's diameter and nearly 400,000 times its luminosity. To say larger hardly captures the meaning. If the Sun were a modest house, Alnilam would be a sprawling city glowing with endless fire. These comparisons begin to stretch language itself, for how do we describe such immensity in human terms? The giants of light are so far beyond us that even numbers feel inadequate. And yet, by comparing them to our sun, we find a fragile foothold to grasp their scale. When you imagine these stars, close your eyes and picture them not as abstract points of light, but as glowing spheres. Place the sun as a golden bead in your palm, then picture Deneb as a vast balloon filling an entire room, Rigel as a tower stretching beyond mountains, Alnilam as a sphere so large it could engulf entire orbits. To see them this way is to turn data into image, science into poetry. The giants of light are not just bigger, they are overwhelming presences, cosmic bonfires burning against the darkness. And yet, there is a curious truth in all this. Though they dwarf the sun in size and brightness, they are rarer. The galaxy is filled with billions of stars, but only a few are blue supergiants. Most stars, like Proxima Centauri, are small, faint, and long-lived. The giants are spectacles, but the dwarfs are the norm. This too is part of the rhythm of comparison. Grandeur dazzles, but simplicity endures. The sun, as an average star, belongs to the great majority, while Deneb and Rigel are outliers, rare notes in the galactic song. Their brilliance is all the more precious because it is fleeting and uncommon. The giants of light also remind us of destiny. For all their size, for all their power, they cannot escape the inevitable. When they end violently, collapsing in on themselves and exploding in bursts so powerful they can briefly outshine an entire galaxy. From those explosions come the elements that form planets, oceans, and even life. The iron in your blood, the calcium in your bones, the oxygen you breathe, these were forged in the hearts of giant stars long ago. So, in a way, we too are comparisons of scale. We are small beings, yes, but made of the ashes of giants. Their size, their fire, their destruction are written into the atoms of our bodies. To dwell upon this thought is to feel both humbled and uplifted. We are tiny, yet we carry the memory of immensity. When you look at the sun, and then imagine Deneb, Rigel, or Alnilam, you are not just comparing stars, you are comparing lifetimes, destinies, and legacies. The sun sustains us quietly. The giants blaze and then vanish, leaving behind the raw materials of creation. Both scales are needed. Both roles are sacred. And so, we drift gently onward, carrying the vision of these luminous giants. They are reminders that the universe is not uniform, that scale shifts with every step, and that beauty exists in both moderation and excess. The giants of light may outshine our sun, but they also teach us the value of balance, for without a modest star like ours, life would not endure. Without the giants, however, the ingredients for life would not exist. Each comparison reveals not superiority, but connection. As our journey continues, we prepare to meet another class of titans, not the hot blue giants, but the cool red behemoths that swell to sizes almost beyond comprehension. If the blue supergiants are the torches of the galaxy, the red supergiants are its vast lanterns, glowing with gentle fire across unfathomable distances. To see them is to encounter yet another layer of scale, another whisper of infinity, another reminder that size has many forms. From the dazzling blaze of blue supergiants, our journey drifts towards stars that burn differently, slower, cooler, but even larger in sheer dimension. These are the red behemoths, swollen titans that stretch across space with bloated atmospheres, their gentle crimson glow betraying a scale so vast it defies comprehension. If the giants of light stunned us with brilliance, the red supergiants astonish us with size. To compare them with our sun, or even with the blue supergiants we have just left, is to step yet again into a new realm of infinity. Consider Betelgeuse, the shoulder star of Orion, familiar to anyone who has gazed at the winter sky. To the naked eye, it glows with a faint orange-red hue, steady, yet somehow fragile. But apparence déceive. Betelgeuse is so large that if it were placed at the center of our solar system, it would engulf Mercury, Venus, Earth, and even Mars. Its radius is hundreds of times greater than that of the Sun, stretching across more than 1 billion kilometers. Picture the Sun as a modest bead of light, and Betelgeuse as a colossal balloon that could swallow the orbits of planets whole. The comparison is almost absurd. The star that looks like a speck in our sky could, in reality, eclipse nearly everything we know. And then there is Antares, the heart of the constellation Scorpius, glowing with a deep red light that makes it one of the most striking stars in the heavens. Antares is often called the rival of Mars because of its similar color, but in truth, it dwarfs the red planet 1,000-fold. Antares is roughly 700 times the diameter of the Sunday. Imagine placing the Sun beside it. The Sun would appear like a tiny spark next to a glowing ember the size of an entire city. If Betelgeuse feels vast, Antares feels almost impossible, a swollen sphere of gas that challenges the limits of what a star can be. These red behemoths are nearing the ends of their lives. Where blue giants burn hot and fast, red supergiants swell as they age, their outer layers expanding while their cores collapse. They are fragile in structure, their atmospheres so diffuse that if you were to fly through them, the gas would feel thinner than a vacuum on Earth. They are stars on the brink of transformation, preparing to end their existence in cataclysmic supernovae. Yet in their fragile enormity, they embody a strange beauty, glowing gently across the night sky, as if whispering their last lullabies before death. To compare the Sun with Betelgeuse, or Antares, is to compare a candle with a bonfire, or a pebble with a mountain. The scale is beyond human experience. Imagine Earth, a marble. Place beside it the Sun, a beach ball. Now replace the Sun with Betelgeuse, a sphere as wide as an entire stadium. Its faint light glowing softly, yet covering a volume millions of times greater than our star. The imagination strains at such comparisons, but they help us feel the immensity rather than simply know it. What makes the red supergiants even more astonishing is their distance. Betelgeuse is about 642 light-years away, Antares around 550. And yet, even from these immense distances, their light reaches us clearly, outshining nearby stars. The fact that something so far can still appear bright is itself a measure of scale. For a star to be visible across hundreds of trillions of kilometers, it must be extraordinary, and so they are. But their grandeur is temporary. The red behemoths are unstable, their outer shells trembling with pulsations, shedding gas into space in great plumes. One day, Betelgeuse will collapse, exploding in a supernova that could briefly outshine the full moon in our sky. For weeks or months, the night will be pierced by its brilliance before it fades to silence, leaving behind a neutron star or perhaps a black hole. The comparison then shifts again, from size to consequence. For though they are vast, their end is violent, and their legacy is to scatter heavy elements into the galaxy, the raw material for planets, oceans, and life. In a sense, we are tied to these giants. The calcium in our bones, the iron in our blood, the oxygen in the air, all were forged in the hearts of ancient red supergiants that died long before the Sun was born. Their size was not simply spectacle, it was function. They swelled, they exploded, they seeded the universe, and from that seed, our world emerged. To compare ourselves with Betelgeuse is not only to feel small, but also to feel connected. We are, in the quietest way, the children of these swollen stars. Antares, Betelgeuse, and others like the Mu Cephei, sometimes called the Garnet Star, form a gallery of red lanterns in the night sky. Each one is a reminder that size takes many forms. The blue giants dazzled with heat and brightness. The red behemoths astonish with breadth and fragility. To compare them is to compare different kinds of magnificence, each one expressing the vastness of the cosmos in its own way. As you let these images drift in your mind, imagine standing in the center of a cosmic hall of mirrors. On one side, the blue giants blaze fiercely, short-lived but stunning. On the other, the red supergiants loom vast and swollen, their light softer but their presence overwhelming. In the middle, our sun glows steadily, modest yet balanced, enduring while others flare and fade. The comparison becomes less about numbers and more about rhythm, a dance of lifespans, a balance of scales. And yet, even as enormous as Betelgeuse and Antares are, they are not the largest stars we know. There are still greater ones, hypergiants, titans that dwarf even these red behemoths, stretching across scales so vast that the mind falters. The path of comparison is endless, each step revealing yet another horizon of enormity. The giants we have met are vast, yes, but they are only waypoints on the journey outward. Beyond them lies something even larger, even stranger, awaiting our gentle curiosity. So we drift onward, leaving behind the soft glow of Betelgeuse and the fiery heart of Antares, carrying with us their lesson. That immensity does not always shine fiercely. Sometimes it glows gently, and that even the most fragile structures can be the largest. With calm wonder, we prepare to meet the hypergiants, the colossal monarchs of the stellar kingdom, whose scale will again stretch imagination to its limits. The journey through the stars has already revealed scales that stretch imagination, our sun humbled by Sirius, dwarfed by Rigel, eclipsed by Betelgeuse and Antares. Yet even these immense red behemoths are not the end of the road. Beyond them, scattered across the galaxy, lie stars so large, so bloated, so overwhelming in dimension that they are given a category of their own, hypergiants. These are the true monarchs of the stellar kingdom, titans whose very existence defies the language we use to describe size. To compare them with the sun is to compare a single drop of water with an ocean, or a stone with an entire mountain range. Take Uy Scuti, often considered one of the largest stars ever measured. Its radius is more than 1,700 times that of the Sunday. If you placed it at the center of our solar system, its outer edge would stretch far beyond the orbit of Jupiter. Imagine that for a moment. Mercury, Venus, Earth, Mars, the asteroid belt, and even Jupiter, all swallowed within its swollen body. The Sun, which once felt like the ultimate giant, becomes a mere speck against such immensity. Numbers hardly capture it. You could line up hundreds of suns across the diameter of Uy Scuti, and still the star would extend beyond them. Its sheer volume is so great that nearly 5 billion suns could fit inside. Then there is Vy Canis Majoris, another hypergiant whose reputation has fascinated astronomers for decades. Once estimated to be even larger than Uy Scuti, current measurements suggest its size fluctuates, for stars like these are unstable and shifting. Yet even in its smallest estimate, Vy Canis Majoris is over 1,000 times the Sun's radius. It is not a neat sphere, but a trembling, convulsing mass, shedding its outer layers into space in colossal clouds of gas. To imagine it is to picture a red lantern so vast it could swallow orbits whole, its surface boiling with storms larger than entire planetary systems. Hypergiants are fragile by nature. They are not stable like our sun, burning quietly for billions of years. Instead, they live dangerously close to collapse. Their immense size means that gravity and pressure struggle to hold them together, and they lose mass in great waves of stellar wind. They are stars at the very edge of possibility, swollen to their maximum before death claims them. To compare them with Earth is almost nonsensical, like comparing a mountain to a grain of sand. And yet, by placing them side by side in our imagination, we come to understand the sheer spectrum of scale the universe holds. Picture Earth, a marble in your palm. Place beside it the sun, now a great beach ball glowing with warmth. Now place Scuti beside that, a sphere so large it could fill an entire stadium, dwarfing everything we know. Even Jupiter, the largest planet, would be nothing more than a speck of dust floating within its volume. The act of imagining these comparisons brings both wonder and calm. We see our place, small but clear, within the grand hierarchy of the cosmos. But perhaps the most humbling thought is that even these hypergiants are rare and temporary. They live fast, they swell quickly, and they die young. A star like Scuti will not endure for billions of years. Instead, it will collapse in a violent supernova, scattering its layers into space, leaving behind a black hole or neutron star. Its immensity carries within it the seed of its own destruction. The comparison here is not only about size, but about fragility. The larger the star, the shorter its life. The giants of moderation, like our sun, live long and steady. The hypergiants flare, tremble, and vanish. These titans are also reminders of perspective. From Earth, Scuti is invisible to the naked eye. Despite its unimaginable size, its distance of nearly 9,500 light-years dims its light. We see Deneb, Betelgeuse, and Rigel, but Scuti hides quietly, its brilliance spread thin across distance. This, too, is a lesson of comparison. Size does not always mean presence. Even the greatest giants can go unnoticed when they are far away. Imagine for a moment drifting close to such a star. Its surface would not look like the sun's bright, defined disk. Instead, it would be a blurred, trembling horizon of gas, stretching beyond vision. The light would be red and heavy, casting eerie shadows across space. You could travel for hours, days, weeks at the speed of light and still not cross its diameter. And yet, despite its vastness, you would know it was fragile, an immense balloon on the verge of bursting. In the cosmic hierarchy, hypergiants stand as monuments to excess. They remind us that the universe explores every possibility, from the smallest dwarfs that burn gently for trillions of years, to the largest behemoths that flare brightly and die young. By comparing them with our sun, we see balance. Our star may be modest in size, but its steadiness has allowed life to flourish. Scuti may be colossal, but its lifespan is fleeting, its story one of grandeur without longevity. Scale, once again, is not about superiority, but about balance. As we let these comparisons settle in our minds, there is a quiet peace in realizing that we do not live beside a hypergiant. Life as we know it could not exist in its violent light. Instead, we orbit a steady, average star, one that shines just enough, for just long enough, to nurture us. To be small is not always a weakness. Sometimes, as in the case of Earth and the Sun, it is a gift. Yet still, the hypergiants invite awe. They are the peaks of possibility, the ultimate expression of scale in the stellar world. To know they exist is to understand that the universe does not hold back. It creates in whispers and in shouts, in pebbles and in mountains, in tiny worlds like Pluto, and in titans like Scuti. Each comparison reveals another layer of infinity, another way of seeing our place within the whole. And so, as we drift away from the realms of hypergiants, we prepare to change the scale once more. For stars are vast, yes, but they are still only single points of light in something larger. Beyond individual stars lie gatherings, clusters, groups, and swarms of stars bound together. To compare a single giant with a cluster is to take another step outward, another soft breath in the journey toward infinity. The hypergiants leave us humbled, but they also leave us ready to see how the universe arranges its lights, not only as solitary giants, but as communities of brilliance. We leave behind the solitary monarchs of the cosmos, the hypergiants, immense and fragile, and turn now to something different. If individual stars are the words of the universe, then clusters are its sentences, woven together into larger meaning. A cluster of stars is more than a gathering. It is a chorus, a family, a reminder that scale can grow not only through size, but through number. To compare a single star, even a hypergiant, with an entire cluster, is to step again into wonder, into the realization that immensity takes many forms. Consider the Pleiades, perhaps the most famous star cluster in the night sky. Known since ancient times, it shines as a small smudge of light in the constellation Taurus, often mistaken for a tiny cloud. Through the eye alone, you may see 6 or 7 stars, but in truth, the Pleiades contains more than 1,000. Each of those stars is young, hot, and bright, burning blue against the darkness. Imagine our sun among them. It would seem modest, quiet, almost invisible beside these brilliant siblings. The comparison is not only about brightness, but about multitude. A single star, no matter how vast, is only one. A cluster is many, gathered together in harmony. Open clusters like the Pleiades are nurseries of the galaxy. Stars are born in clouds of gas and dust, collapsing under gravity, igniting into fire. Sometimes they emerge in families, groups of dozens or hundreds, still bound by the gravity that birthed them. To compare such a cluster with our lonely solar system is to see difference in community. Earth circles a single sun, but in the Pleiades, planets would rise beneath skies filled with multiple stars, each casting its own light. The scale of life there, if it exists, would be drenched in radiance. Then there are globular clusters, grander still, vast spherical swarms of stars bound tightly together. Omega Centauri is one of the most stunning examples. A cluster containing perhaps 10 million stars. Imagine the sun multiplied by millions, each burning close together, crowding into a dense sphere. If you lived within such a cluster, the night sky would not be dark at all. It would blaze with hundreds of suns visible at once, each one as bright as the moon appears to us. The comparison to our quiet sky is staggering. We see darkness sprinkled with stars. They would see a sea of light, a sky forever ablaze. Globular clusters orbit the Milky Way like satellites, ancient remnants from the early days of the galaxy. Some are nearly as old as the universe itself, 12 or 13 billion years in age. To compare their lifespan with our sun's youth is to feel the weight of time as scale. Where our star is middle-aged, these clusters have endured almost since the beginning. Their persistence is their size, their scale expressed not just in number of stars, but in epochs of history. Imagine drifting slowly into such a cluster. Stars crowd around you in every direction, not distant pinpricks, but blazing neighbors. You could travel a fraction of a light year and pass near several suns. The concept of isolation vanishes. The cosmos becomes dense, alive, crowded. And yet, despite this density, the cluster as a whole is still vast, spanning dozens or even hundreds of light years. The paradox of clusters is that they are both crowded and immense, intimate yet infinite. Comparison here takes on another layer. A hypergiant like UY Scuti dwarfs the Sun in size, but a globular cluster dwarfs even UY Scuti in scale by sheer number. The star may be vast, but the cluster is multitudinous. It is the difference between a single towering mountain and an entire range stretching across the horizon. The Sun may pale beside Betelgeuse, but Betelgeuse itself is only one among millions in a cluster. To see them side by side is to understand that scale can be individual or collective, singular or communal. The beauty of clusters has always touched human imagination. The Pleiades are found in myths across cultures: Japanese, Greek, Native American, and more. Their appearance in the night sky has been a signal of seasons, a guide for agriculture, a spark for stories. Omega Centauri, though faint to the naked eye, dazzles through a telescope, revealing a swarm so rich it almost defies vision. These stories remind us that comparison is not only a scientific exercise, but also a human one. We compare because we seek meaning, and clusters offer meaning in abundance. There is also a kind of comfort in clusters. Stars are not always alone, drifting silently through the void. Sometimes they are born together, travel together, age together. This companionship, seen on such a vast scale, mirrors our own longing for connection. Just as humans form families, communities, and societies, so too do stars. To compare our sun's isolation with the companionship of clusters is to see our place more clearly. We live beside a single star, yes, but we belong to a galaxy filled with families of light. And still, even clusters are not the end of the journey. For while they may contain thousands or millions of stars, they themselves are only fragments of galaxies. The Milky Way holds over 100 billion stars, arranged not as a cluster but as a sprawling spiral. To compare a cluster with a galaxy is to step again into astonishment, realizing that even the most crowded gatherings of stars are but threads in a larger tapestry. So the lesson of clusters is both simple and profound. That scale is not only measured in the size of one, but in the company of many. A single hypergiant may dwarf the Sun in dimension, but a cluster dwarfs the hypergiant in multitude. Each comparison shifts our perspective, showing us that infinity does not belong to one form, but to all forms, layered upon each other like waves. As we leave behind the Pleiades, Omega Centauri, and the countless other clusters shimmering across the galaxy, we carry their image with us. A reminder that the universe builds not only giants, but gatherings. Not only singularity, but community. With this gentle thought, we turn toward the next stage of comparison: the spirals, the galaxies, the grand structures that contain even these vast swarms of stars. What is a cluster beside a galaxy? Soon, we will see. From the clustered brilliance of the Pleiades and Omega Centauri, our gaze now widens again. We drift outward, leaving behind the swarms of stars bound tightly together, until they appear like tiny motes suspended in space. As our view expands, a new form emerges, grander, more intricate, and more beautiful than anything we have yet seen. The clusters fade into the background, and the sweeping arms of galaxies take their place. This is the spiral stage of the cosmos, where scale becomes not only immense, but also breathtaking in symmetry. Our home galaxy, the Milky Way, is the perfect example. When you look at the night sky, the faint band of light stretching across the heavens is not a cloud, but the combined glow of billions of stars, each one too distant to be seen individually, but together they form a shimmering river of light. The Milky Way contains around 400 billion stars, spread across a disk more than 100,000 light-years wide. If a globular cluster feels like a city of stars, then a spiral galaxy is a continent, vast and sprawling, its arms winding like graceful ribbons through the void. To compare a cluster with a galaxy is to compare a village with a nation. In Omega Centauri, millions of stars shine together. In the Milky Way, hundreds of billions form spiraling arms, laced with gas clouds, nebulae, and dark dust lanes. Place a cluster beside a galaxy, and the difference is overwhelming. Even the grandest globular cluster becomes a spark in the galaxy's lantern. This is the rhythm of scale once more. What seemed immense is revealed to be only small when set against the next layer. The structure of a spiral galaxy is delicate yet immense. At its heart lies a bulge, a crowded core of stars orbiting a supermassive black hole. From this center, arms unfurl, winding outward in graceful arcs. Within those arms, stars are born in glowing nurseries of gas, live their lives in quiet or brilliance, and die in explosions that scatter dust and light. The arms are like the strokes of a cosmic brush, painting swirls across the canvas of night. The comparison with clusters is striking. Where clusters are dense and spherical, galaxies are vast and sweeping, elegant in their order. If you could place the Sun within this scale, and indeed it is placed, you would find it in the quiet suburbs of the Milky Way, about 27,000 light-years from the center, circling slowly in its orbit. Our solar system takes more than 200 million years to complete one circuit around the galaxy. That means the last time Earth was in its current position, the dinosaurs walked upon its surface. The timescale of galactic comparison adds another dimension. Not only are galaxies larger, but their rhythms are slower, their movements stretched across epochs far beyond human measure. Other spiral galaxies reveal the same beauty on even larger scales. Andromeda, our nearest galactic neighbor, is about 220,000 light-years, across twice the width of the Milky Way, and holds perhaps 1 trillion stars. Imagine comparing our galaxy to Andromeda. The Milky Way, vast as it is, becomes only half as large as this neighbor, and in 4 billion years, the two will collide, merging into a new form, a galactic dance of unimaginable scale. To picture this is to imagine two glowing whirlpools drifting toward one another, their arms intertwining, stars flung across space, yet most never colliding because of the distances between them. Comparison here is both a story of size and of destiny. Other spirals, like the majestic Whirlpool Galaxy M51, showcase the structure in near perfection, its arms clearly visible, lined with star-forming regions that glow pink against the dark. Viewed from afar, such galaxies remind us of shells, hurricanes, or fingerprints, patterns that echo nature on every scale. When we compare a spiral galaxy to a cluster, the thought arises that nature repeats itself, always building from small gatherings into larger structures, always weaving parts into wholes. The sheer number of stars within a spiral galaxy is staggering. To imagine them, think of every grain of sand on every beach on Earth. Now imagine each one as a star. The Milky Way holds even more than that. And then, multiply again for each galaxy beyond. Numbers falter under such immensity, but comparison keeps us grounded. One cluster may dazzle with millions of stars, but a spiral galaxy holds hundreds of billions, all arranged in a structure so vast that light itself takes 100,000 years to cross it. There is also mystery here. The graceful arms of galaxies are shaped not only by visible stars and gas, but by the hidden presence of dark matter. Without it, the stars would scatter, the arms would unravel. So when we compare galaxies, we must remember that much of their scale is invisible, carried not by light, but by unseen mass. Just as the Sun holds the solar system together, dark matter holds galaxies in place. Comparison, then, is not only about what we see, but about what we cannot. For us, the Milky Way is not just a galaxy, it is home. Every star you have ever seen in the night sky belongs to it. Every story, every myth, every dream under the heavens has been written beneath its light. To compare our home galaxy with others is to understand that we live not in isolation, but in community. The Milky Way is one among billions, each with its own billions of stars, its own swirls and secrets. Our galaxy is vast, yes, but it is also typical. And in its typicality lies a strange comfort. We belong to something immense, yet not alone. As you drift through the thought of spirals, picture yourself hovering above one, arms unfurl below, glowing rivers of light curling into the darkness. The core blazes with a brilliance greater than any cluster, while the edges fade into wisps of gas. To see such a structure is to feel calm, awe, a gentle recognition that beauty exists at scales far beyond us. And yet, even as immense as galaxies are, they too are part of larger patterns. For galaxies gather into groups, into clusters of their own, into webs that stretch across the universe. And so, the spiral stage teaches us another lesson of comparison. Size grows not only in dimension, but in organization. From stars to clusters, from clusters to galaxies, the pattern repeats, small pieces joining to form larger wholes. We are not lost in chaos, but part of a structure, a rhythm of assembly that echoes through the cosmos. With this thought, we prepare for the next step, to compare galaxies themselves, to see how even these spirals, grand as they are dwarfed by the giants among them. As we float gently through the spiraling arms of the Milky Way, it is tempting to think of galaxies as singular giants, each one already so immense that further comparison seems unnecessary. But just as stars come in many sizes, from faint red dwarfs to bloated hypergiants, so too do galaxies span an extraordinary range. Some are tiny, fragile things, containing only a few million stars. Others are incomprehensible leviathans, holding trillions, their glowing arms stretching for millions of light-years. To place them side by side in imagination is to feel once again the universe's fondness for scale, its endless habit of layering small within large, large within larger still. Let us begin with the smallest, dwarf galaxies. Unlike the sweeping elegance of spirals, dwarf galaxies are modest, often irregular in shape, sometimes resembling faint smudges of light rather than defined structures. The small Magellanic Cloud, one of our galactic neighbors, is a prime example. Barely 7,000 light-years across, it holds about 3 billion stars. To compare, the Milky Way spans over 100,000 light-years and contains hundreds of billions of stars. Imagine setting a small pebble beside a mountain range that is the scale between the small Magellanic Cloud and our own galaxy. And yet, despite their modest size, dwarf galaxies are numerous. They swarm around larger galaxies like satellites, companions that whisper of the universe's preference for the small. The large Magellanic Cloud is another such neighbor, larger than its smaller sibling but still tiny compared to the Milky Way. At about 14,000 light-years wide and with 30 billion stars, it seems almost delicate. And yet, within it lies the Tarantula Nebula, one of the most active star-forming regions known, glowing with fierce energy. This contrast teaches us again that scale is not everything. Even a small galaxy can host extraordinary phenomena, just as a small world like Earth can nurture life while giants like Jupiter remain barren. Now let us drift outward to larger forms. Our Milky Way, though vast, is only average among spirals. Andromeda, its nearest great neighbor, is more than twice as large, spanning over 220,000 light-years and perhaps containing 1 trillion stars. Place the Milky Way beside Andromeda, and suddenly our home seems modest, its 400 billion stars overshadowed by the immensity of its rival. And yet, in 4 billion years, the two will merge, becoming one vast elliptical galaxy. The comparison here is not just about size, but about destiny, reminding us that scale is dynamic, always shifting, always preparing for the next transformation. Beyond Andromeda lies a gallery of galactic giants. Take Messier 87, the massive elliptical galaxy at the heart of the Virgo cluster. nearly 980,000 light-years across. It contains several trillion stars and hosts a supermassive black hole, so vast it can be imaged from Earth. To compare M87 with a dwarf galaxy is like comparing an ocean with a droplet of rain. Even the Milky Way pales beside its enormity, a reminder that our home, though vast, is not exceptional in the grand scale. And then there is IC 1101, one of the largest galaxies ever observed. Spanning nearly 6 million light-years and holding perhaps 100 trillion stars, it stands as a true leviathan. If the Milky Way were a coin in your hand, IC 1101 would be a sprawling city stretching beyond sight. Its scale is so great that it almost becomes abstract, a reminder that the universe builds structures not just of grandeur, but of extremes. To compare Earth with Jupiter humbled us. To compare the Sun with Betelgeuse astonished us. But to compare the Milky Way with IC 1101 pushes us towards silence, for words themselves falter under such immensity. What makes these contrasts even more striking is that galaxies, no matter their size, follow the same basic rules. They are collections of stars, dust, gas, and dark matter bound by gravity. Whether small or large, each galaxy holds within it the same processes. Stars are born, they shine, they die, they enrich their surroundings. The comparison is one of scale, not of essence. A dwarf galaxy and IC 1101 are built of the same materials, governed by the same laws, yet one is a whisper and the other a roar. Imagine for a moment, lining them up in your mind. The small Magellanic Cloud appears first, a fragile glow of 3 billion stars. Then the Milky Way, its spirals stretching wide, holding 400 billion. Then Andromeda, twice as broad, shining with 1 trillion. After that, M87, nearly 1 million light-years across, a fortress of trillions of suns. And finally, IC 1101, sprawling across 6 million light-years, glowing with the light of hundreds of trillions. The ladder of size climbs steeply, each rung almost absurdly greater than the one before. And yet, all are galaxies, all members of the same cosmic family. This contrast reveals something profound about perspective. To us, the Milky Way feels infinite. It is our home, our sky, our map of the heavens. But when placed beside IC 1101, it is reduced to modest proportions. And still, for the stars within it, for us, it remains vast enough. Scale is relative, always shifting with the point of comparison. What is small in one view is immense in another. Just as Earth feels grand to those who walk its mountains, so too does the Milky Way feel grand to us, even if larger galaxies exist. There is also a philosophical lesson in this. The dwarfs remind us of abundance. There are far more small galaxies than large ones. The giants remind us of extremes, of what is possible when the universe stretches itself to its limits. Both are necessary for the story of creation. Without dwarfs, galaxies like the Milky Way would lack companions, sources of new stars and material. Without giants, the universe would lack its monuments, its grand structures of awe. Comparison shows not hierarchy, but harmony. And so we drift gently through this gallery of contrasts. The dwarfs, faint and numerous. The spirals, balanced and common. The giants, rare and magnificent. Each plays its role. Each adds its voice to the cosmic song. And as we leave this stage, we prepare for the next. For galaxies themselves do not exist alone. They gather, too, into communities, bound by gravity into clusters of galaxies. To compare a single galaxy, no matter how vast, with an entire cluster is to climb yet another rung in the ladder of infinity. the scale will shift again, and with it, our sense of wonder. After wandering through the contrasting scales of galaxies, from the fragile whispers of dwarfs to the sprawling immensity of IC 1101, we return to something closer to home, the Milky Way. Our galaxy may not be the largest, nor the smallest, but in its balance lies a quiet beauty. To see it clearly, we must step back, not with telescopes or instruments, but with imagination. By comparing the Milky Way with its neighbors, with giants, and with dwarfs, we begin to understand its true nature, its rhythm, and its role within the universe's endless hierarchy of scale. The Milky Way stretches about 100,000 light-years across, a spiral with graceful arms winding around a luminous core. Within it reside between 300 and 400 billion stars, along with nebulae, dust, and dark matter that together form a system of astonishing intricacy. To compare it with Andromeda, our nearest large neighbor, is to see humility. Andromeda is larger, brighter, and contains more stars. To compare it with dwarf galaxies, however, is to see grandeur. Our home holds hundreds of billions, where they hold only millions. In both comparisons, the truth is the same. Scale is relative. What is modest in one measure is immense in another. To imagine the Milky Way, picture a vast city at night, glowing with billions of lights. Each light is a star, each cluster a neighborhood of suns. Some districts shine with youthful brilliance, hot stars, newly born in glowing nebulae. Others are older, dimmer, filled with ancient red dwarfs still burning quietly after billions of years. The galactic arms are avenues of creation, spirals lined with nurseries, while the core is a dense downtown, crowded and brilliant. The comparison with a human city is imperfect, of course, but it gives us a sense of familiarity. Just as cities hold multitudes of lives and stories, so too does the Milky Way hold multitudes of stars and worlds. At the very center of this galactic city lies Sagittarius A*, a supermassive black hole with the mass of about 4 million suns. To compare it with any star is futile. It is not a star at all, but the collapsed remnant of unimaginable density. And yet, its gravity binds the galaxy together, orchestrating the orbits of stars across tens of thousands of light-years. The Milky Way's structure exists because of this invisible anchor. Even in the heart of immensity, it is the unseen that provides order. When we place the Milky Way beside other types of galaxies, we see its balanced nature. Elliptical galaxies like M87 are vaster, but they are also older, quieter, lacking the vibrant star formation of spirals. Dwarf galaxies are more numerous but simpler, their stars fewer and less organized. The Milky Way sits comfortably between extremes, rich with ongoing creation, but also seasoned with ancient stars. Its scale is neither modest nor overwhelming. It is the middle ground of galactic design. Perhaps it is in this middle ground that life finds its best chance, for balance often nurtures possibility. Consider again the dwarf galaxies that orbit the Milky Way. The small and large Magellanic Clouds, faint patches of light in the southern sky, are companions bound by gravity, circling our galaxy, like moons circle planets. To them, the Milky Way must appear colossal, a dominant neighbor pulling them into its embrace. To us, however, they are reminders that even great structures are not alone. Galaxies travel in groups, in clusters, in communities. The Milky Way belongs to the local group, a gathering of about 50 galaxies, including Andromeda, Triangulum, and many dwarfs. Within that family, our galaxy is significant but not supreme. This perspective shifts again when we imagine the future. In about 4 billion years, the Milky Way will collide with Andromeda, their spirals merging into a single elliptical form. To compare today's Milky Way with its future self is to realize that scale is never fixed. The galaxy we know will vanish, not in destruction, but in transformation. Stars will be flung into new orbits, clusters will dissolve, new patterns will emerge. The very identity of our galaxy will change. Comparison here becomes not only spatial but temporal, today's grandeur set against tomorrow's greater whole. And yet, for us, here and now, the Milky Way is enough. It is the stage upon which every human story has unfolded, every dream beneath the stars, every voyage of discovery. From within, it feels infinite, stretching across the sky as a glowing river. From outside, it is one among billions, an ordinary spiral in an ordinary corner of the cosmos. Both views are true, and both are necessary. For scale is not only about measurement, it is about meaning. Picture yourself drifting far above the galactic plane, looking down upon the spiral arms. They sweep outward in elegant curves, studded with light, reaching across 100,000 light-years of space. Each point is a Sunday. Around many of those suns, planets circle, some barren, some perhaps alive. Among them lies Earth, a fragile dot in a fragile arm, its presence undetectable against the immensity. And yet, from that dot comes consciousness, reflection, the very act of comparison itself. The Milky Way may be immense, but it is within its immensity that we find the space to wonder. The Milky Way also teaches us about limits. Light travels fast, yet even so, a beam from one side of the galaxy takes 100,000 years to reach the other. In human terms, this is eternity. Civilizations could rise and fall in the time it takes a single photon to cross the disk. To compare our lifespans, measured in decades, with galactic timescales, is to feel humbled. But it is also to feel serene, for it shows us that the universe is patient, that it moves in rhythms slower than our worries, deeper than our fears. So where does the Milky Way sit in the ladder of scale? It is not the smallest, not the largest, but somewhere in the middle. Its comparison with dwarfs shows us abundance, with giants shows us humility, and with itself shows us balance. Perhaps this is its gift, to be ordinary, and in being ordinary, to host something extraordinary life. Out of 400 billion stars, one small planet carries oceans, forests, and thought. Compared with the galaxy, Earth is nothing. Compared with Earth, the galaxy is everything. And in that duality lies wonder. As we let the image of our galaxy settle in the mind, we prepare to step outward once again. For just as stars gather into clusters and galaxies into spirals, galaxies themselves gather into even larger formations, clusters of galaxies. To compare a single spiral, even the Milky Way, with an entire cluster, is to widen our vision yet again. The ladder of infinity still stretches upward, and we are only midway. The perspective of the Milky Way comforts us, but the next step will astonish us anew. From the quiet perspective of the Milky Way, vast yet still modest compared with giants like IC 1101, we now drift outward once again. The galaxy, which once felt infinite, begins to shrink in our view. As we retreat farther, we notice something profound. Galaxies themselves are not isolated. They are drawn together, pulled by gravity into families far larger than any single spiral or elliptical could ever be. These are the clusters of galaxies, immense gatherings that reveal yet another step in the universe's endless ladder of scale. The local group, to which our Milky Way belongs, is the first step into this realm. It is a collection of more than 50 galaxies, ranging from giants like Andromeda and the Milky Way to numerous dwarfs that hover nearby. To compare a single galaxy with the local group is to compare a single voice with a choir. The Milky Way, vast as it is, becomes only one member of a greater ensemble. Together, The galaxies move through space, bound in a slow, intricate dance that will continue for billions of years. But the local group is small compared with the giants among clusters. Consider the Virgo cluster, a swarm of more than 1,300 galaxies located about 65 million light-years away. Its gravitational pull is so immense that even the local group drifts slowly toward it, as though drawn by a quiet current in the cosmic ocean. Within Virgo lies Messier 87, the massive elliptical galaxy we encountered earlier, surrounded by countless companions. To compare the Milky Way with the Virgo cluster is to compare a single drop with a storm. A galaxy may feel immense, but in the cluster's embrace, it becomes just another participant in a grander structure. Beyond Virgo lies the Coma cluster, even larger, containing thousands of galaxies spread across tens of millions of light-years. Imagine drifting through such a region. Galaxies glowing all around you like fireflies, each one itself containing hundreds of billions of stars. The comparison stretches imagination to its limit. A cluster like Coma holds so many galaxies that if you tried to count them, you would run out of lifetimes before you finished. And yet, they are not scattered randomly. They are held together by gravity, bound in a cosmic community. What makes clusters especially humbling is their scale not only in size but in mass. Most of the matter within them is not visible stars or glowing gas, but dark matter, an unseen substance that outweighs everything we can see. Without dark matter, the galaxies would drift apart. With it, they hold together in structures spanning millions of light-years. To compare a galaxy's mass with a cluster's is to recognize how much of reality is hidden from sight. The Sun holds the solar system together. Dark matter holds the clusters. Scale is built not only from light, but from shadow. There is also beauty in imagining what it would be like to exist within such a cluster. From Earth, we see the Milky Way's band, a soft stripe of light across the sky. But from deep inside a rich cluster, the heavens would blaze with hundreds of galaxies visible to the naked eye, glowing as bright as stars appear to us. Nights would not be dark at all. They would shimmer with countless neighboring galaxies. The comparison to our sky is almost unimaginable. What feels like emptiness to us would feel like fullness to them. Clusters also reveal the slow rhythm of cosmic motion. Galaxies within them orbit their common center, moving at hundreds or even thousands of kilometers per second. Collisions are frequent on cosmic timescales, spirals merging into ellipticals, stars flung into intergalactic space. To compare the quiet orbit of Earth around the Sun with the turbulent motions of galaxies in a cluster is to sense the difference between local calm and grand chaos. The solar system feels serene, but on the scale of clusters, the universe is dynamic, restless, alive. And yet, for all their immensity, clusters are only part of something greater. They themselves gather into superclusters, immense webs of galaxies stretching across hundreds of millions of light-years. The Virgo cluster is but one member of the Laniakea supercluster, a vast region that contains our local group and tens of thousands of other galaxies. To compare a single cluster with a supercluster is to step once more into astonishment, realizing that scale has no upper bound. Every time we think we have reached the top of the ladder, another rung appears above. But let us pause for a moment with clusters themselves, to appreciate their role. Without clusters, the universe would be scattered, lonely. With them, the cosmos forms communities, structures where galaxies share gravity, share motion, and share destiny. They are the meeting places of the universe, the towns and cities of the cosmic map. Just as stars gather into clusters and humans gather into societies, galaxies gather into clusters, following the same rhythm of assembly that echoes at every level. The comparison between the Milky Way and a cluster humbles us, but it also comforts. It shows that we belong to something larger, that our galaxy is not alone in the void. It is part of a neighborhood, part of a network, part of a story greater than itself. To know this is to feel less isolated, to understand that even at scales where distance stretches beyond imagination, connection remains. As we drift away from the Virgo and Coma clusters, we carry with us their image, vast spheres of light, each one containing thousands of galaxies, each galaxy containing billions of stars, each star perhaps carrying worlds. The scale cascades downward, from clusters to galaxies, from galaxies to stars, from stars to planets, from planets to people. And yet it also cascades upward, from clusters to superclusters, from superclusters to walls and filaments, until the entire universe becomes a web of light. And so, with quiet awe, we prepare for the next comparison. If clusters of galaxies are immense, what about the structures even larger? The walls, the filaments, the cosmic web that stretches across the observable universe. To place a cluster beside such vastness will once again shift our perspective, showing us that scale, like infinity, has no end. As we drift away from the swirling gatherings of galaxy clusters, we notice a deeper pattern beginning to emerge. The Virgo cluster, the Coma cluster, even the mighty Laniakea supercluster, they are immense, but they are not scattered randomly across space. Instead, they line up, join hands, and form structures even larger than themselves. These are the walls of the universe, the filaments and sheets of galaxies that stretch like scaffolding across the cosmos. To compare a cluster with one of these walls is to compare a single mountain with an entire continent, a local peak with the range that stretches beyond the horizon. One of the most famous of these structures is the Sloan Great Wall, discovered in 2003 through the Sloan Digital Sky Survey. It is a cosmic barrier of galaxies more than 1.4 billion light-years long. Imagine that for a moment. Light, which circles Earth 7 times in a second, would take 4 billion years just to cross its length. Every galaxy within it, billions of stars in each, is only a dot in the larger pattern. To compare the Milky Way with the Sloan Great Wall is to place a grain of sand beside the Great Wall of China, then expand the metaphor until both dissolve into insignificance. And the Sloan Wall is not alone. The Hercules Corona Borealis Great Wall, discovered in 2013, is even larger, estimated to be more than 10 billion light-years across. This structure is so vast that it challenges our very understanding of the universe's uniformity. Cosmologists long believed that on the largest scales, matter should smooth out, becoming evenly distributed. But the Great Wall shows otherwise. It is as if the universe has woven itself into a tapestry, threads of galaxies forming filaments, knots, and ridges that span across unimaginable expanses. To compare such a wall with a single galaxy cluster is to compare the thread of a spider's web with the entire forest that holds it. Picture these walls in your mind. They are not solid like stone, but networks of galaxies, glowing dots connected by invisible filaments of dark matter. Between them lie vast voids, cosmic hollows, where almost nothing exists, each one millions of light-years wide. The walls define the shape of the universe, not by what they are, but by what they leave empty. Comparison here is subtle. The universe builds itself not only with presence, but also with absence, with light and with shadow. The cosmic web, as astronomers call it, is the largest structure we know. Galaxies are the letters, clusters are the words, walls are the sentences, and the web is the story itself. To compare our solar system with this web is to place a raindrop beside an ocean, a single note beside a symphony. And yet, despite the overwhelming scale, there is beauty in its pattern. Like frost spreading across glass, or veins branching through a leaf, the universe arranges itself with elegance, repeating the same forms on every scale. The lesson of the walls is that immensity is not chaos. From afar, the Sloan Great Wall appears like a ridge of light, the Hercules, Corona, Borealis Wall, like a river stretching across the cosmos. Within them, galaxies swirl and stars are born, but from a distance, they form structure, order, harmony. To compare them with the smaller scales we have traveled through is to see that the universe is fractal in spirit, repeating itself in ever grander echoes. The solar system holds planets orbiting a star. Clusters hold galaxies orbiting a center. Walls hold clusters threading across the void. The pattern repeats, only the scale changes. For us, living on Earth, these walls are beyond reach. We will never travel to them, never touch them, never cross their full extent. And yet, through telescopes, we can map them, draw their outlines, and know they are there. To compare the time it takes us to walk across a city with the time it would take light to cross a wall is to feel humbled, but also soothed. For while we are small, we are still capable of perceiving, of imagining, of understanding. Our minds stretch where our bodies cannot. Even the voids between the walls carry meaning. These vast empty spaces, sometimes 100 million light-years wide, are like the dark between stars, the silence between notes. Without them, the pattern would vanish. The comparison is not only about what exists, but about what does not. A galaxy cluster is immense, but it is the emptiness around it that defines its place in the cosmic web. The walls remind us that scale is both fullness and emptiness, both presence and absence. And so, as we let these colossal walls settle in our minds, we understand that the universe is not random, but ordered, not chaotic, but patterned. To compare the Milky Way with the Sloan Great Wall is to see our galaxy as a single thread in a vast tapestry, woven with billions of others into a design that spans the observable universe. Each comparison humbles us further, but also lifts us into wonder. The walls are immense, but even they are not the final boundary. For beyond the filaments and voids lies the horizon of the observable universe itself, the ultimate comparison. To place the walls beside the full span of the cosmos is to realize that even billion light-year structures are still only pieces of a greater whole. Infinity always extends one step further, always whispers another comparison. And so, with quiet awe, we drift once again. We leave behind the Sloan Great Wall, the Hercules, Corona Borealis Wall, the cosmic filaments stretching across the night. We carry their image like veins of light across darkness, like rivers glowing in the void. And we turn our gaze toward the next horizon, the edge of what we can see, the boundary of the observable universe. If walls humble us, the limit itself will silence us. For there, scale ceases to be comparison and becomes something more an invitation to wonder at what lies beyond. Beyond the filaments and walls, beyond the rivers of galaxies woven into the cosmic web, lies a boundary not of matter, but of light. It is called the observable universe, the farthest distance from which light has had time to reach us since the beginning of cosmic history. To compare a cluster of galaxies with this limit is to compare a single step with an endless journey, or a candle's glow with the rising sunday. For the observable universe is not just large, it is the largest horizon our eyes can ever truly know. The universe is about 13.8 billion years old, and since light travels at a finite speed, there is only so far we can see. Yet, because space itself has expanded, the edge of the observable universe is not 13.8 billion light-years away, but closer to 46 billion. Imagine a sphere surrounding us in every direction, 92 billion light-years across, filled with all the galaxies, stars, and structures we can ever detect. Everything we have compared so far, planets, stars, galaxies, walls, is contained within this sphere. And beyond it, there may be more, perhaps infinitely more, but we cannot see it. The comparison here is ultimate. What is known versus what is hidden. Picture the scale in your mind. The Milky Way, so vast with its 100,000 light-year span, becomes less than a grain of sand in this cosmic sphere. The Sloan Great Wall, 1.4 billion light-years long, becomes a mere thread inside. Even the Hercules, Corona Borealis Great Wall, stretching 10 billion light-years, fits within the edge like a ridge inside a globe. To compare the observable universe with any structure inside it is to see how even the grandest walls are themselves small, like cracks in the paint of a vast dome. And yet, the observable universe is not empty. Within it lie an estimated 2 trillion galaxies, each containing billions or trillions of stars. That means the observable cosmos holds more stars than all the grains of sand on all the beaches of Earth. To hold this number in your mind is impossible. It washes over you like the sound of waves. Each grain of sand a star, each handful a galaxy, each shore a cluster, and still the beaches of Earth fall short. Comparison collapses under the weight of such immensity. At the edge of this observable sphere lies not familiar galaxies, but faint light, the cosmic microwave background. It is the afterglow of the Big Bang, radiation that has traveled for nearly 13.8 billion years to reach us. To compare it with the sun's light is to compare a whisper with a shout, faint and cold, yet filled with meaning. It is the oldest light we can see, the boundary of sight itself. Beyond it lies darkness, not because nothing exists, but because no light has yet had time to arrive. When you imagine this horizon, let it settle gently. The observable universe is not the universe in total. It is only the part visible to us. There may be regions beyond, larger, stranger, forever hidden. But for us, the limit is enough. It is a bubble of light, a shell of vision, a reminder that comparison always ends with perspective. For while the sphere is vast, we stand at its center, not because we are special, but because every observer, anywhere, would also stand at the center of their own observable universe. Scale here is not only vast, but symmetrical, repeating wherever consciousness resides. The timescales embedded in this comparison are as staggering as the distances. Light that left distant galaxies billions of years ago is only now reaching us. To look at the edge is to look into the past, to see the universe as it was when it was young. The comparison with our present-day cosmos is startling. Galaxies still forming, stars just beginning to ignite, the first elements swirling into clouds. The observable limit is not only spatial but temporal. It is a window into time itself. And still, we ask, what lies beyond? Here, comparison falters, because beyond the observable horizon, we cannot see. Perhaps the universe is infinite, stretching forever in all directions. Perhaps it is curved, looping back upon itself like the surface of a sphere. Perhaps it holds regions entirely unlike ours, with different stars, different laws, even different dimensions. To compare what is visible with what may lie beyond is to compare a room with the world outside its walls. We know our chamber of light, but beyond its door lies mystery. To reflect upon the observable limit is to feel small, but also strangely calm. The sphere is immense, but it is also finite, giving us boundaries to hold in our thoughts. Within its 92 billion light-years, all of history unfolds. The birth of stars, the dance of galaxies, the rise of life. Everything we have ever known or imagined exists inside this horizon. The comparison with infinity may overwhelm, but the comparison with ourselves reminds us that within this immensity, we still find meaning. Imagine then, floating at the edge of this observable sphere, looking outward into the dark beyond. You see no stars, no galaxies, only the fading glow of the microwave background, like the last embers of a dying fire. Behind you stretches everything: clusters, walls, galaxies, planets, and home. Ahead lies silence. The comparison becomes personal. We are finite beings gazing into the infinite, bounded by light, yet reaching with thought. And in that reaching, we become part of the scale itself. So the observable universe stands as both limit and invitation. It is the largest comparison we can make, the widest horizon we can see. Beyond it lies speculation, but within it lies wonder enough to lull us into awe. As we let this vision rest in our minds, we prepare to shift perspective again. For scale is not only measured in space, it is also measured in what is unseen: dark matter, dark energy, the invisible forces that shape even the observable universe. The next step will show us how even within this vast sphere, much of reality remains hidden. We have reached the boundary of the observable universe, that luminous sphere where the oldest light still whispers across space. From here, it feels as though we have seen it all: planets, stars, clusters, galaxies, and the grand web itself. But there is a deeper truth waiting quietly behind the veil. For most of the universe is not what we can see. The galaxies, the shining stars, the luminous nebulae, these are only the decorations on the surface. Beneath them lies a hidden architecture, an invisible depth that shapes everything. To compare the visible universe with the invisible is to realize that what we see is only the tip of a cosmic iceberg. Astronomers have long puzzled over a mystery. When they measured the mass of galaxies and clusters, they found that visible matter, the stars, planets, and glowing gas, was not enough to hold them together. Galaxies spin too quickly. Clusters bind too strongly, for the gravity of visible matter alone to suffice. Something unseen provides the missing weight, the glue that holds structures intact. This hidden mass is called dark matter, and it makes up about 27% of the universe. By comparison, ordinary matter, all the stars, planets, and people, accounts for less than 5%. The rest, a staggering 68%, is something stranger still: dark energy, the force that drives the universe's expansion. To imagine this is humbling. Everything we have compared so far, all the luminous beauty of the cosmos, represents only a fraction. If the universe were an ocean, the stars would be the foam upon its surface, bright but shallow. Beneath lies the water, deep and invisible, holding the true mass. To compare what is seen with what is unseen is to see ourselves as children playing on the shore of a vast sea, glimpsing only the waves, while the depths remain unfathomed. Dark matter does not shine, does not absorb light, does not interact with electromagnetic radiation. We cannot see it directly, but we can trace its presence through gravity. It bends the paths of galaxies. It sculpts the cosmic web. It ensures that stars remain bound in spirals rather than flung into space. Imagine trying to map the wind by watching trees bend and rivers ripple. You cannot see the wind itself, but you know it is there. Dark matter is the same, invisible, yet undeniable. The comparison with visible matter is staggering. For every star we see, there is 5 times as much dark matter silently present. And then there is dark energy, stranger still. In the late 20th century, astronomers discovered that the expansion of the universe is not slowing, as once thought, but accelerating. Something is pushing galaxies apart, stretching the fabric of space itself. This invisible force is dark energy, the dominant ingredient of the cosmos. To compare it with anything we know is difficult, for it is not matter at all, but a property of space, a kind of pressure woven into the universe. Yet, by its effect, it overwhelms everything else. Galaxies shine, but dark energy rules. The invisible depths change our perspective completely. When we looked at the observable universe, we thought we saw the whole. Now we realize we saw only a fraction. It is as if we gazed at a vast city at night, marveling at the glowing windows, only to be told that most of the buildings were hidden in shadow, their walls unseen but essential. Comparison here is almost paradoxical. The unseen outweighs the seen. The hidden defines the visible. Reflect on what this means for our earlier comparisons. We placed Earth beside Jupiter, Jupiter beside the Sun beside Betelgeuse, Betelgeuse beside galaxies, galaxies beside walls, and all within the observable universe. Yet beneath every step, dark matter was there, shaping, binding, pulling. Without it, galaxies would scatter, clusters would dissolve, the web would unravel. Without dark energy, the expansion would falter, the balance would collapse. What seemed like the ultimate scales are themselves built on invisible foundations. The thought is humbling, but also soothing, for it shows us that mystery remains, that the universe still holds secrets untouched by human knowledge. To compare what we know with what we do not is to see the balance between light and shadow, between certainty and wonder. The visible cosmos comforts us with beauty. The invisible cosmos invites us with mystery. Both are needed to lull the mind into awe. Imagine drifting through the cosmic web again, this time with new eyes. The glowing galaxies are like fireflies, but around them lies an unseen lattice of dark matter, vast filaments connecting clusters across space. You cannot see them, but you feel their presence, like the subtle touch of air on your skin. And in the background, everywhere, dark energy stretches the fabric, pushing the galaxies apart, expanding the very stage upon which the play unfolds. The visible is the performance, the invisible is the theater. Some philosophers have compared this balance to human life. What we show, what we see in one another, is only the surface. Beneath lie invisible depths, memories, emotions, thoughts, unspoken forces that shape who we are. In the same way, the universe shows us stars and galaxies, but beneath them lie forces unseen, shaping the story. To compare the cosmos with ourselves is to recognize a mirror, the visible and the hidden, the known and the unknown, together making the whole. And so, as we let the idea of invisible depths settle in our thoughts, we prepare for yet another step in comparison. For if space is vast, so too is time. The scale of the universe is not only measured in light years, but in ages, epochs, lifespans. To compare a human life with the life of stars, to compare the history of Earth with the history of galaxies, is to discover another dimension of immensity. Beyond the invisible matter and energy, there lies the infinite reach of time, and that is where our journey will turn next. Up until now, our comparisons have been measured in size, diameters, distances, volumes, the physical immensity of worlds and stars. But there is another scale, quieter yet just as profound, that threads through every level of the cosmos. It is time. If space is the canvas upon which the universe is painted, then time is the rhythm of its unfolding. To compare in time is to realize that size is only half the story. The other half lies in duration, in how long things last, in the tempo at which the universe breathes. Consider first the fleeting span of a human life. Measured against the life of a star, it is a blink, less than the flicker of a candle. If you lived 100 years, it would still be nothing beside the billions of years that stars endure. To compare a century with cosmic epochs is to see how quickly we pass across the stage, yet also to recognize the miracle of existing at all within such immensity. Our lives are small, but they are framed by the grandeur of the whole. Our sun, for example, has already burned for 4.6 billion years and will likely burn for another 5 billion. Its total lifespan is about 10 billion years, a vast duration compared to us, but modest compared to the universe itself. A star like the Sun is steady, middle-aged, living in balance. To compare the Sun's 10 billion years with the fleeting lives of massive blue giants is to feel another kind of awe. Rigel, Deneb, or Al-Nilam may shine brighter and larger, but they will live only a few million years before collapsing in violent deaths. The comparison in time is as staggering as the comparison in size. Small stars live long, giant stars die young. Endurance belongs to the modest. At the other end of the scale are red dwarfs, the most common stars in the galaxy. They are dim, cool, and small, often less than half the Sun's size, yet their lives stretch for trillions of years. The universe itself is only 13.8 billion years old, which means not a single red dwarf has yet lived out its full life. To compare their lifespans with the age of the cosmos is to realize that the story of stars is still at its beginning. Long after the Sun has faded, long after galaxies have changed their shapes, red dwarfs will still be burning, steady beacons in the distant future. The same contrast appears in galaxies. Our Milky Way has existed for more than 13 billion years, nearly as old as the universe itself. It has endured collisions, grown by swallowing smaller galaxies, and will one day merge with Andromeda to form a new whole. To compare the age of the Milky Way with the age of a human civilization is almost absurd. Rome lasted 1,000 years, Egypt's kingdoms a few thousand, human history perhaps 10,000. These are sparks against the backdrop of billions, and yet even sparks can light the dark. In that comparison lies both humility and beauty. Time also reveals itself in the evolution of the universe itself. The first stars were born about 200 million years after the Big Bang, faint lights flickering in a dark cosmos. Galaxies assembled slowly. Clusters gathered, walls formed. Over billions of years, the structures we now see came into being. The comparison between the early universe and today is staggering. Then, the cosmos was simple, filled mostly with hydrogen and helium. Now, it brims with heavy elements, planets, and perhaps countless worlds of life. Time is not just duration, it is transformation. Even the observable universe itself has a lifespan. It is expanding, stretching faster and faster under the influence of dark energy. Billions of years from now, galaxies beyond our local group will drift out of sight, carried beyond the observable horizon. The comparison between what we see today and what future observers will see is sobering. To them, the cosmos may appear emptier, the sky quieter, the great web of galaxies vanished into darkness. Time does not only reveal, it also conceals. For us, time feels fleeting, but for the universe, it is vast, patient, unhurried. To compare human history with cosmic history is to see two different rhythms. We measure in decades and centuries. The cosmos measures in eons and ages, yet the two scales are intertwined. Every human breath, every heartbeat, is powered by the Sun, which itself is one chapter in the galaxy's long story. The atoms in our bodies were forged in stars billions of years ago. Time connects us backward, across generations of stars, and forward into futures we cannot imagine. Philosophers have often spoken of time as a river. For us, it feels like a rapid stream, carrying us swiftly from birth to death. For the universe, it is a slow and endless flow, carving valleys, building mountains, shaping galaxies. To compare our river with the cosmic river is to realize that we are drops within drops, moments within moments. Yet each drop reflects the sky. Each moment contains the whole. And so, when we add time to our comparisons of scale, the picture becomes richer. Earth is small compared to Jupiter, but its history is vast compared to our lives. The sun is modest compared to Betelgeuse, but it endures longer. Red dwarfs are small compared to the sun, but they outlast everything. Galaxies are immense compared to clusters, but they too will merge, dissolve, and transform. Time is the dimension that reveals the hidden balance between small and large, brief and long, fragile and enduring. Imagine, then, standing on Earth beneath the night sky. You see stars whose light left them thousands or millions of years ago. You gaze at galaxies whose glow began its journey before humanity existed. Every glance into the heavens is also a glance into the past, a silent comparison between now and then. And as you stand there, your own life passes in minutes and hours, fleeting against the backdrop of billions of years. Yet both scales are real, both matter, both are part of the same universe. So we carry with us the lesson of time, that size is not the only measure of scale, that endurance and brevity are equally profound. A star's brilliance may be fleeting, but its death sows the seeds of new worlds. A human life may be brief, but within it can lie love, thought, and memory, things no measure of years can diminish. The cosmos may endure for ages, but without moments like ours, its grandeur would have no witness. Comparison, once again, is not about superiority but about perspective. As we drift onward, we turn from time itself to the smallest and most personal comparison of all. After stars and galaxies, after clusters and walls, after billions of years and light years, we return to ourselves. The next step will be to reflect on the human place in this immensity, tiny, fragile, yet luminous in our own way. The scale of the cosmos humbles us, but it also asks a question: how small are we really? And what does it mean to exist within such vastness? We have traveled outward across so many rungs of infinity, past planets and stars, past clusters and galaxies, past the very edge of the observable universe, and even into the invisible depths of matter and time. Each comparison has humbled us, showing how small our world seems beside the vast structures of the cosmos. And now, gently, we turn the lens back upon ourselves. For the truest comparison of all may not be Earth against Jupiter, or the Sun against Betelgeuse, but humanity against the universe itself. What does it mean to be small? And how small are we, really? Picture Earth again, that fragile marble of blue and white floating in the black. It is already tiny compared with Jupiter, a speck compared with the Sun, invisible against the immensity of the Milky Way. And upon this marble live nearly 8 billion humans, each one carrying memories, thoughts, and dreams. Place a human being beside Earth, and the contrast is staggering. Our bodies no taller than a whisper against mountains, our lifespans no longer than a blink against oceans of time. To compare a person with the cosmos is to see a candle flickering beneath a sky filled with suns. And yet, there is a quiet paradox. For while we are small in body, we are vast in awareness. The same mind that fits within the narrow span of a skull can hold galaxies in imagination, can measure the distances of stars, can map the cosmic web itself. A single human can think thoughts that span billions of years and trillions of kilometers. The brain, no larger than a melon, can carry the image of the entire universe. To compare physical scale with mental scale is to discover that our smallness hides an inner immensity. Every comparison we have made so far, Earth and Jupiter, Sun and Rigel, Milky Way, and IC 1000, 101, exists because human beings looked outward and asked, how large, how far, how long? The universe reveals its scales, but it is human curiosity that strings them together, building ladders of meaning. We are both the smallest observers and the authors of the comparison itself. Without us, size would still exist, but scale would not be measured. The paradox deepens. In being small, we also give voice to the large. Reflect for a moment on the fragility of life. The distance between Earth and the edge of the observable universe is 46 billion light-years. Yet the distance between birth and death for us is measured in decades. To compare these spans is to feel fragile, yet it is also to see value. Our brevity sharpens meaning. Just as a supernova blazes brightly for only a short time, so too does a human life shine with intensity, precisely because it is brief. The grandeur of galaxies may last for eons, but it is the passing nature of our days that gives them depth. And there is another layer still. Though small, humanity has begun to touch the scales beyond itself. We have walked upon the moon, sent probes across the solar system, and extended our instruments to the edge of the observable universe. To compare the reach of our technology with the reach of our bodies is to see how scale can be extended through tools, through thought, through imagination. We cannot stride across light years, but our machines can send us images of galaxies billions of years old. We cannot live for billions of years, but our writings, our stories, our legacies carry fragments of us forward. In this way, we stretch ourselves beyond our size. There is comfort, too, in knowing that we are not alone in our smallness. All beings, from ants crawling on the earth to whales swimming in the ocean, share the same stage of existence. Compared with the universe, all of us are fragile sparks. And yet, together, we form patterns of connection, families, cultures, civilizations. Just as stars gather into clusters and galaxies into webs, so too do humans gather into communities. Our smallness, when joined together, becomes something larger than any one of us. Comparison here becomes not about diminishment, but about belonging. Imagine standing under the night sky. Above you stretch the stars, glowing with light that has traveled for millions of years. Beneath you rests Earth, old and silent, spinning steadily on its axis. And between the two, there you are, small, yes, but conscious, aware, capable of wonder. To compare yourself with the universe is to feel humility, but also intimacy. For though the cosmos is vast, it flows through you. The atoms in your body were forged in stars, the iron in your blood born in the death of giants, the carbon in your cells shaped in stellar furnaces. You are not apart from the universe, but of it. Small, yes, but made of infinite things. Even the act of sleep, for which these words are meant, carries a kind of cosmic parallel. As you drift into rest, your mind floats outward, untethered, into a space without measure. In dreams, distances vanish, time dissolves, and scale loses its hold. You become both small and vast, both body and imagination. The comparison is poetic. Just as the universe expands endlessly, so too does the dream expand within you. The macrocosm and the microcosm echo one another. So how small are we really? If we measure by size, we are tiny, almost invisible against the immensity of the observable universe. If we measure by time, our lifespans vanish beside the lives of stars and galaxies. But if we measure by meaning, by awareness, by the capacity to reflect and wonder, then we are not small at all. We are the scale itself, the rulers who measure infinity, the mirrors in which the cosmos sees itself. Without us, size is silent. With us, size becomes story. And so we rest within this paradox. Fragile bodies beneath infinite skies, fleeting lives within eternal time, small creatures with vast imaginations. To compare ourselves with the universe is to be humbled, but also to be uplifted. We are small, but not insignificant. We are tiny, but luminous. In us, the universe has found a way to reflect upon its own immensity. That reflection is its gift to us, and our gift in return. From here, the journey turns homeward. We have traveled outward across every rung of scale, and now we prepare to close the circle. For the final comparison is not outward, but inward. Back to Earth. Back to the fragile blue marble, where it all began. The next step will be to return home, to see our world anew, small yet precious, set within the cosmic ocean. And in that return, the story of scale will find its gentle conclusion. We have drifted outward across every rung of the cosmic ladder, from the quiet scale of Earth to the immensity of planets, from stars to clusters, from walls to the observable universe itself. We have compared, step by step, and felt the vastness press gently upon our imagination. And yet, as all journeys do, this one leads us back to where we began. After tracing the infinite, we return home to Earth, the fragile sphere of oceans and clouds, the place where comparison is not abstract, but lived. Imagine looking back now, after wandering to the farthest horizons. The Milky Way shrinks behind you, the walls of galaxies blur into threads, the cosmic web folds into a distant shimmer. You fall gently inward, past superclusters, clusters, spirals, stars, and planets, until at last you arrive again at the small blue marble suspended in space. Earth, no larger than a grain of dust against the universe's scale, waits quietly. And as you settle your gaze upon it, you realize that this return is not anticlimax, but revelation. For all that immensity, all those comparisons, have only deepened the significance of this home. Earth is 12,700 kilometers wide. Compared with Jupiter, it is small. Compared with the Sun, it is tiny. Compared with Betelgeuse, it is invisible. And yet, compared with us, it is immense oceans that span horizons, mountains that scrape the sky, forests that breathe life into air. Scale, as we have learned, is always relative. What dwarfs one thing magnifies another. For us, Earth is not small at all. It is shelter, sustenance, stage, and sanctuary. As we reflect, the comparisons we have carried through this journey begin to soften. It is no longer about numbers or measurements, but about balance. Earth's size is perfectly tuned, not too small to lose its atmosphere, not too large to crush life beneath gravity's weight. Its orbit is at just the right distance from the Sun to keep water liquid, its tilt just right to give us seasons, its rotation just right to give us days and nights. To compare Earth with other planets is to see that it is not the largest or the smallest, but the most suited for life. It is not scale that defines its greatness, but harmony. And within this harmony lies the story of everything we know. Every poem ever written, every song ever sung, every step taken by human feet, these belong to Earth. From the perspective of the galaxies, our world may vanish into insignificance. But from the perspective of meaning, Earth contains universes of its own. It contains you. It contains us. To compare Earth with the cosmos is to understand that significance is not only measured in kilometers or light years, but in memory, consciousness, and love. Consider again the images of Earth seen from afar, the pale blue dot captured by Voyager 1, the Earthrise seen from Apollo 8. In those photographs, Earth looks impossibly small, a mote of light against endless dark. And yet, as Carl Sagan once said, within that dot lies everyone you love, everyone you know, every story of humankind. The comparison between appearance and reality could not be greater. Small in sight, vast in meaning, fragile in size, infinite in significance. Returning home after traversing the scales of the universe is like waking from a dream. You carry with you the memory of stars larger than imagination, of walls spanning billions of light years, of mysteries hidden in invisible depths. But you also carry the recognition that you live upon a world where rivers flow, where forests grow, where voices laugh and weep. The grandeur of the cosmos makes Earth not less, but more precious. For in all our comparisons, We have yet to find another place like it. And so, the final comparison is not Earth against Jupiter, or the Milky Way against IC 1101. It is Earth against absence, a world filled with oceans and life, compared with the silent void. In that comparison, Earth wins immeasurably. Its smallness becomes its strength, its rarity, its value. The universe may be vast, but it is this fragile sphere that gives us breath, story, and meaning. As you let these thoughts settle, imagine standing on Earth once again. Above you, the stars wheel slowly across the night sky. Beneath you, the ground is steady, ancient, holding the weight of generations. You are small, yes, but you are also home. And within that home lies the power to wonder, to dream, to compare, to gaze into the infinite and find peace. The journey has carried us outward into immensity and back again into intimacy. It has shown us that scale is endless, but meaning is here. And so, as the story of size draws to a close, you may allow yourself to drift gently towards sleep, held within the embrace of Earth, cradled by the arms of the cosmos itself. And so, dear traveler, our long journey draws to a close. We have wandered across scales so vast they strain imagination, from the pebble of Earth to the giant sweep of galaxies, from clusters and walls to the very edge of the observable universe. Each step has humbled us, reminding us that we are small in body but vast in awareness. Each comparison has been not only a lesson in size, but also in meaning. Now, as we return home, let the images soften. The stars blur into a quiet glow, the galaxies into faint clouds, the walls into whispers. The cosmos folds gently into the background, leaving only the rhythm of your breath, the steady beat of your heart. You no longer need to measure, to compare, to imagine. You are here, present, resting within the embrace of night. Remember this: the universe is immense, but you belong within it. You are made of its atoms, shaped by its history, carried by its rhythms. You are both small and infinite, fragile and enduring. And as you close your eyes, you are part of the same cosmic silence that holds the stars. So let go now. Let the vastness slip away, like waves retreating into the sea. Let the weight of the day dissolve into calm. You are safe. You are held. You are home. The universe is vast, yes, but tonight it has folded itself into a lullaby, carrying you toward dreams. Sleep well, and may the quiet of the cosmos guide you gently into rest.